Assalamu alaikum and hello everyone. This is Miraj Kamran in Explore Chemistry. Today I'm going to show you a video related to salts, properties of salts and types of salts. So let's start this video. First of all, I'll tell you what are salts. There are many types of salts and with different properties they exist in nature. Chemically, salts are compounds which contain ionic bond. As you know, there are different types of bonds: ionic bond, covalent bond, coordinate covalent bond. So the compound which contain ionic bond is called as salts. In an ionic bond, always there is a cation and anion. As you know, ionic bond is formed between anion and cation due to the transfer of electron. So these salts also contain a cation and anion. So these cations and anions come from different compounds, different elements. They can be metal and non-metal. Salts are always neutral in nature because charges are similar. Cations contain positive charge, anions contain negative charge. So they have equal number of charges which make them neutral, electrically neutral. So salts are basically ionic compounds containing ionic bonds. Now we'll discuss some properties of salt. First of all, salts are neutral to pH, means the pH value is 7. So on the pH scale, you can see over here the pH value lies. Salts are combination of cations which come from metals and anions which come from non-metals. Metals are electropositive in nature. Whenever they combine with another element, they always donate their electrons, whereas non-metals are electronegative in nature, they gain electrons. So in this compound of sodium chloride, sodium is giving its electron to chlorine and chlorine is accepting that electron. Due to the loss of electrons, sodium has converted into cation, positively charged ion, and due to the gain of electron, chlorine has converted into anion, negatively charged ion. So, in a salt, there is a metal which exists as cation and non-metal which exists as anion. Another example you can see here, calcium is attached with chloride ion. Calcium is a metal, so it is containing plus charge. Plus 2 charge means it is a cation. And chlorine is a non-metal, it is containing minus 1 charge, so it is an ion. Another property of salt is salts are crystalline in nature due to strong electrostatic force. As you know, ionic bonds or ionic compounds are formed between cation and anion. So there is a strong force of attraction between negatively charged ion and positively charged ion. So they take the positions in a crystal in the form of crystal lattice, and their position becomes fixed, means they cannot move due to the attraction of positive and negative ions. Their positions become fixed. So they take the structure of crystalline lattice. Due to this strong electrostatic force, salts have high melting and boiling point. If anyone wants to melt any salt, he or she has to break this electrostatic force which has generated due to positive and negative charges. Then only compound molecules will go far from each other. They will take the shape of liquid only. Then whenever this strong electrostatic force is broken. So to break this strong electrostatic force, high temperature is required. Therefore, salts have high melting point. Salts are soluble in water. As you know, water is a polar compound. It is also having positive and negative charge. So, positive charge of water molecule will attract negative charge of salt, and it will break this negative charge or take that negative charge away from the crystal. Similarly, Negative charge of a water molecule will attract positive charge of salt and it will break down this bond in this way. Therefore, all salts, because they contain positive and negative charges, therefore they are soluble in water. Salts may contain water of crystallization, for example, hydrated copper sulfate. Its formula is written like this. Simple copper sulfate formula is CuSO4. Hydrated means water of crystallization is attached with the molecule. In many salts, water of crystallization is attached to give the salt a perfect crystal shape. In this diagram, you can see copper sulfate is attached with water of crystallization. This molecule is showing water crystallization. Now we will discuss formation of a salt. Salts are basically product of neutralization reaction. A reaction in which an acid reacts with a base. For example, HCl is an acid and NOH is a base. When these two react together, they will form NaCl and water or salt and water. So, this reaction is known as neutralization reaction and this type of reaction always a salt is formed. So, salts are product of neutralization reaction. This is the formula of a salt NaCl which has formed in this reaction. If we will focus on the equation, Na is cation which came from a base. So, this cation is always a basic radical in a salt. Cl negative is an anion and it is the part of acid. So it is acidic radical. So in every salt, cation came from base or it is known as basic radical and anion is known as acidic radical. In a salt, number of cations and anions may differ, but the charges are equal. Positive and negative charges are equal. Therefore, a salt becomes neutral, electrically neutral. Now we will discuss some types of salts according to their structure. First one is normal salt. These salts are electrically neutral salts and formed by the complete neutralization reaction of an acid and a base. Examples of such salts are NaCl, very common example sodium chloride, which is also known as table salt. Another example is potassium nitrate, formed as KNO3. Another example is copper sulfate. All these are normal salts which are formed by simple complete neutralization reaction. Let's see how these normal salts are formed. Sodium chloride, as I have told you, it will form by the reaction of HCl acid and sodium hydroxide base. Potassium nitrate, it will form by the reaction of HNO3, nitric acid and potassium hydroxide. When these two will combine, the formula of salt will be KNO3 potassium nitrate. This cation has came from base and this anion of the salt has came from acid. Another example is copper sulfate. It can be formed by the reaction of sulfuric acid H2SO4 and copper hydroxide CuOH2. When these two will react, it will form copper sulfate, a salt, a normal salt and water. In copper sulfate, copper radical has came from base and sulfate radical has came from acid. So in this way, a normal salt can form by simple complete neutralization reaction. Another type of salt is acidic salts. These salts are formed by incomplete neutralization of a polybasic acid. It can be dibasic acid or tribasic acid with the base. Means whenever a polybasic acid reacts with the base, through incomplete neutralization reaction, acidic salts are formed. Examples of these type of salts are sodium bisulphate, NaHSO4. Another example is sodium bicarbonate, NaHCO3, which is also known as baking soda. Let's see how these acidic salts are formed. Sodium bisulphate is formed by the reaction between a basic acid, sulfuric acid, and a monoacidic base, sodium hydroxide. When these two will react, sulfuric acid is having two hydrogen. Through incomplete neutralization reaction, it can make only one hydrogen, and the formula of salt will become NaHSO4. So out of two hydrogen, one hydrogen is still over here. So it is showing incomplete neutralization reaction. So this salt is an example of acidic salt which is having hydrogen radical in the center. So in this way you can recognize any salt having hydrogen in the center, it will be known as acidic salt. The neutralization reaction doesn't stop over here. This compound can again undergo neutralization reaction with simple base. In this step, in next step, this only one hydrogen will also remove from here and it will convert into Na2SO4 plus H2. This sodium sulfate is considered as normal salt. So through the neutralization reaction of any basic acid, two types of salts can be prepared, acidic salt and normal salt. Through incomplete neutralization, we will get acidic salt. Through complete neutralization reaction, we can get normal salt. Another example of acidic salt is sodium bicarbonate, which can be prepared by incomplete neutralization of carbonic acid H2CO3 and sodium hydroxide. Here you can see carbonic acid is again basic acid. So through incomplete neutralization reaction, only one hydrogen will remove from here and sodium will take the position of that hydrogen. It will become NaHCO3. So charge on Na is positive, on H is positive, CO3 is having -2 charge. So you can see number of positive and negative charges are equal, but number of cations and anions are unequal. Due to the presence of this H in the center, this sodium bicarbonate is considered as acidic salt. It can undergo another neutralization reaction with sodium hydroxide, and in this step this remaining hydrogen will also remove and sodium will take its position. From one sodium it has become two sodium. So formula of this salt will become Na2CO3 and water. This Na2CO3 is known as sodium carbonate and it is the formula of a normal salt. So through this acid also we can get two salts, acidic salt as well as normal salt. Another type of salt is basic salt. These salts are formed by partial replacement of a polyacidic base with an acid. Now we are talking about polyacidic base. It can be diacidic base or triacidic base. Through incomplete neutralization of these type of bases, basic salts can be prepared. For example, magnesium hydroxychloride is an example of basic salt. Here you can see OH in the center. So in this way you can recognize any basic salt. Another example is zinc hydroxynitrate. Here also OH is in the center, so it will be considered as basic salt. Now I'll tell you how it can be prepared. Magnesium hydroxychloride can be prepared by the reaction of HCl hydrochloric acid, which is a monobasic acid, and magnesium hydroxide, which is a diacidic base. When these two will react through incomplete neutralization reactions, out of these two OH ions, only one will remove, one will stay here. In place of this OH, Cl radical will come here and the formula of salt will become MgOHCl. Here in the center OH is present, so you can say this salt is a basic salt. It will form with the formation of water. So over here, this neutralization reaction is incomplete. It can be completed in next reaction if this remaining OH will also remove by the neutralization reaction with HCl. So another HCl will take its position and it can be removed from here. So the formula of salt will become MgCl2 and water will form. This MgCl2 is a normal salt. So in these reactions also we can get two salts One is basic salt, another is normal salt. By incomplete neutralization reaction of diacidic base, we can get basic salt, and through complete neutralization reaction of such bases, we can get normal salt also. Another example of basic salt was zinc hydroxynitrate. It can be formed by the reaction of nitric acid, which is monobasic acid, and zinc hydroxide, which is diacidic base. To incomplete neutralization reaction, only one OH will remove from here and NO3 will come to make the formula of salt as ZnOH-NO3, and water will form. This zinc hydroxynitrate is an example of basic salt. So this can undergo another neutralization reaction to form normal salt with nitric acid. This OH will remove in the next step and NO3 will take its position. So it will become ZnNO3 2 because the valency of Zn zinc is 2, and water will form. So this type of this salt ZnNO32 is a normal salt. So over here you can see again we can prepare two types of salt through neutralization reaction, stepwise neutralization reaction of a diacidic base. Okay, another type of salt is double salt. These salts are formed by the crystallization of an aqueous solution of a mixture of two different salts. Means two different salt solutions are prepared and these two different salt solutions are crystallized together. So they take the shape of one salt and they can be recognized in this way. You can see most common example of double salt is alum. Through the formula, you can recognize any double salt. In this formula, this is the formula of potash alum or simply alum, which is used for the purification of water normally at our homes. This is the formula of potash alum. Here you can see K2SO4 is a salt. Another salt is Al2SO4 3 aluminium sulfate. These two salts are attached together. They are crystallized together. So they have taken one salt formula. So through their formulas you can recognize that this is a double salt. Another example of double salt is Mohr salt, ammonium iron sulfate hexahydrate. It is formed by the combination of ammonium sulfate and iron sulfate. It can be written like this also. Okay. Now I'll tell you how potash alum is formed. In this reaction, you can see potassium sulfate solution is reacted with aluminium sulfate solution, and due to the formation of solution, water molecules are present here. After evaporation, after crystallization process, these two different molecules have attached together to take the form of one molecule, and this molecule is known as potash alum. Separately, they were known as potassium sulfate, ammonium sulfate, but collectively they are known as now potash alum. It is an example of double salt. Another example of double salt is cyanide. It is formed by the solutions of crystallization of solutions of potassium chloride and magnesium chloride with water. So this is the formula. You can see with the formula you can easily recognize two different salts are attached together. Another type of salt is mixed salt. These salts are made from more than one base or more than one acid, and they have either common cation or common anion. For example, calcium hypochlorite CaOCl2. So here cation is only one but two different anions present. Another example is sodium potassium sulfate. Two different cations but one anion. It means this salt has formed by the reaction of two bases and one acid. Another type of salt is complex salts. These salts contain a complex ion or complex neutron molecule in which there is a central metal ion, and these metals are commonly transition metals, mostly transition metals. These metals are surrounded by number of neutral molecules or negative ions. They have complex structure too. Example is potassium ferrocyanide. Formula is K4 square bracket FeCN6. The structure of this potassium ferrocyanide is like this. These complex salts are mostly colored compounds. Another example of a complex salt is potassium mercuric iodide. Formula is K2HgIO. So here you can see a transition metal is present in both the examples. The structure of potassium mercuric iodide is like this. So these are complex salts. Mostly they contain coordinate covalent bond. Okay. So these were types of salts. I hope you understood everything. If you have to ask anything, you can ask me in comments. If you like this video, please share with your friends and subscribe my channel for more videos. Thank you.